Okay, in this video, what I'm going to do is just kind of dive into some practice problems here. So just on continuity, that is. So looking at this first question, it's one diagram, one graph of f of x. It's kind of a piecewise function here, and then a bunch of questions about it. So let's go through that. Working away top left here, our first question, what is the limit of this function as x approaches 2? And again, just the recap for finding a limit. The limit is, especially if you don't have an equation, it isn't necessarily about plugging in the value of 2. It's about looking at the graph and comparing what happens just before 2 and just after 2. And if they converge as like they're both heading to the same point, then you have a limit. The limit being the point you're heading to from both sides. So in this example, I am heading for x equals 2. Well, from the left, I'm heading towards 1. From the right, if I go kind of trace backwards along my graph towards 2, I'm also heading towards 1. Therefore, the limit of the function as it's approaching 2 is 1. Now, does it actually hit 1? Like if I plugged in 2 into this graph, I don't get 1, but we don't care about that. What we care about is the tendency towards a value. All right, moving on. Limit of the function at 1. So the limit as x approaches 1. Let me erase my stuff there. Okay, well, let's go to 1. And, well, I have a little bit of an issue. From the left, we are tending towards 0. Right before we get to 1, it's like, oh, it looks like we're going to hit 0. And then you look the other direction and you go backwards from the right and you head towards 1. And those people are like, no, 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 we're heading towards 1 in the y direction. People from the left are like, no, 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 we're heading to the 0. When you cannot agree, we say that we do not exist, DNE. It's not the best E, but we'll go with it. So if you find yourself in a situation where you have a graph, you're looking at a particular x value limit, and they do not agree from the left and the right, you just say that the limit doesn't exist. So moving on, limit. X approaching 3. All right, well, here we're going from the left. Everyone on the left is like, yeah, we're heading towards 2. And everyone on the right is like, yeah, we're heading towards 2. Well, we agree, so the limit is 2. The difference between the limit approaching 2 and the limit approaching 3 is that as we approach 3, when we get to 3, the number we think is going to happen is the number that actually happens. We think it's going to be 2, and if you plotted it, you would get 2. If you plotted exactly 3. But the difference is the first one we did, the limit as approaches 2, is it looks like we're heading to 1, and it looks like we're heading to 1. But if you actually plugged in x equals 2, by definition of this function, you would not get that. You would actually get 2 instead of 1. So that's the difference, but the limit does exist for both of them either way. All right. Now we get to one-sided limits. So recapping one-sided limits, we don't have to worry about both left and right. We do what the sign says. So 4 with a minus exponent says, let's look at the limit as it approaches 4. Okay, so here's, let me reset everything here. Okay, here's what we're looking at is 4. But the minus says, I don't care at all what happens as we come from the right. I just want to know, what do we think is going to happen at 4 based on our approach from the left. So when we do that, that means we're doing this. We're approaching from the left. And everyone from the left is like, yeah, we're heading towards 1. And we can all be in agreement. Doesn't matter what happens to the right. It's called a one-sided limit. Okay, now we look and we say, hey, another one-sided limit, let's go back to 1. And if you look previously, we said that the limit of x approaching 1 doesn't exist. But that was because the left side and the right side couldn't agree on a number. Now we're looking at 1 just from the positive, so it says from the right. So here, all we're worried about is from the right. We're ignoring everyone that's looking from the left. From the right, everyone's like, yeah, we're heading towards 1. Okay. So the limit from the right says, yeah, if you were to look at 1, we would expect the y value to be 1. Now we look at the limit as x approaches 1, but now we ignore everyone from the right and we say, hey, everyone on the left, what do you think is going to happen when we get to 1? So those people are all looking at this graph and they're like, oh, right before 1, I bet we're going to hit 0. And we can say that that one-sided limit exists because everyone from the left agrees that it's going to be 0. Moving on. The last two, we have these 1/2 limit. Now, what they're trying to get at with this really is like you're kind of extrapolating data, right? We don't have a tick mark at 3.5 here. If we did, it would be somewhere around there. Well, so what is the limit if I trace that up to here? What do we think that y value is? Well, if we go to 3, we're at 2. If we go to 4, we're at 1. So that is a slope of -1, right? We go over 1, down 1. And in the assumption that this is a straight line, if we went halfway over, then we go halfway down. So halfway down between 1 and 2 says that our limit is 1.5. Same thing here with the limit of 1/2. The limit of 1/2, well, x is 1/2 here. We have the same thing, a over 1, down 1 slope. We're going to go halfway over, meaning we go halfway down. So our limit is 0.5. So that's it. I'm going to stop this video here. Excuse me. I'm going to stop the video here and kind of wrap this up as graphing and finding limits graphically. Next one will be evaluating algebraically.